When solving these equations, so far we've had a couple different strategies. Like if I have two different kinds of trig functions in the equation, like maybe I see a sine squared and a cosecant, one of my main strategies has been to force all the same trig function in the equation. But in this case, that's not going to work. And the big thing that jumps off the page at me when I'm looking at this problem is this angle is x and this angle is 2x. If you want to solve an equation, all of the angle measures should be the same. So one of them is double the other one. So instead of forcing them all to be the same trig function, something that trumps that is to force all the angle measures in the equation to be the same size. So I see sine of 2x, and that is a double angle formula. So I'm going to make a substitution using the double angle formula. Here's our double angle formula. In our case, our variable is x, so the sine of 2x is going to be 2 sine x cosine x. When I make that substitution, that sine of 2x became 2 sine x cosine x. Okay, now, our other strategy has failed us, like forcing them all to be sine or all cosine, but that's okay because when we have everything to one side equal to 0, another just algebraic strategy is everything on one side equal to 0 and then factor. And we do have something in common before and after the plus sign. Before and after, we have a cosine of x in both. So I'm going to be able to factor a cosine of x out front. And then when I take a cosine of x, and there's also a 2 in common to both. So I take out a 2 and a cosine of x. And then if I take a 2 cosine x out of 2 cosine x, I'm left with 1. And I take a 2 cosine x out of this one, and I'm left with sine x. You can redistribute to verify, but then the next thing we're going to use is the 0 property. If I've rewritten an equation so that two pieces multiply together to get 0, the only way that happens is if one of those items is 0. So I'm going to set each piece equal to 0. And now I have these two mini equations to solve. But the good news is my mini equation, see how it only has one trig function in it? And this one only signs in this one. So in the long run, we're okay. We still are going after all the same trig function in an equation. It's just that it took us a little while to get there. Okay, so now I solve. So divide both sides by 2. And 0 divided by 2 is 0. We know to solve this equation, we're looking for an angle measure, cosine comma sine on the unit circle, where the x coordinate is 0. So if you look around on your unit circle for where that happens, that's at pi over 2 and 3 pi over 2. Then to solve this one, I'm going to subtract 1 from both sides. And all points on the unit circle are cosine of theta comma sine of theta. Our angle measure is x. So this is my y coordinate is equal to -1. So looking on our unit circle for where the y coordinate is -1, that happens at 3 pi over 2. And we've solved our equation.